So we're working today on problem 2.4 from samples and populations. And in the previous investigation in 2.3, we were looking at how to find a random sample from a group of 100 students. And we were able to do that and do some calculations on the hours of sleep and the number of movies watched. And we did some class data for that. And we took a sample size of 30. And the question we want to ask ourselves today is, could we do this with a smaller sample, or do we need a bigger sample? What's the ideal, or what would be a good sample size to make sure that our data is and our results are predictable? Because we don't want to have to actually calculate all 100 of these. Actually, we could. Calculating 100 numbers is not the most difficult thing, but again, with any sample size, any population that we take a sample of, we always want to ask ourselves, what's the smallest sample we could take and still have a reasonable result and make good predictions with it. So I'm actually going to use this piece of paper again that I used in 2.3. These were the ones I randomly picked to be in my group of 30 and hours of sleep and movies watched. And so today I'm actually going to start by picking a sample size of just 5, and I'm going to actually use my calculator again to pick people from the list. This time I'm only going to choose a group of 5, so I use this math button here. I just push the math button because I want to pick random numbers from this set of 100 and over to PRB, last one on the right, and then down to random integer. Random numbers integers are whole numbers like 1, 2, 3, 4, 5, negative 1, 2, 3, 4. We're going to actually just do positive whole numbers. So I hit enter and 1, comma, 100. Those are my choices, the numbers 1 to 100. And now it's randomly going to pick somebody out of the list here. And so now I picked number 73. And so on my chart, even though 73 was picked in my previous lesson, I'm actually going to pick it again. I'm actually going to use a marker. This is my sample size of 5, so I'm only going to pick 5 of these. I'm going to put this green mark next to them so I know they're part of that sample. And again, number 41 just got picked, and so 41 is a part of my sample size of 5. And so actually go ahead and highlight these. So this is my sample size of 5, and then number 55. And so that one was picked before, but it gets picked again, because remember, random doesn't necessarily mean it's going to pick somebody new. It's just everybody has the same chance every time. Number 14. And one more. This is a sample size of 5, so it's a very small sample. And number 16. So these are my sample size of 5. Now what I want to do with that sample of 5 is I want to find the mean and median for the sleep hours and the number of movies watched. So I'm going to again use my graphing calculator, and in my statistics plot, I'm going to let my calculator do this work for me. So in the stats, I'm going to put in the list, and I'm going to put in the sleep hours. So 6, 8.3. I'm using list 3 and 4 because I actually have list 1 and 2 with the 30 in them already, so I want all of these. And then 5.5, and then 7.5. And this is just from my list. You should be doing this if you're doing this on your own at home from your own list. And so there's my 5, 1, 2, 3, 4, 5 for sleep hours. And then I'm going to go over to list 4 and put in the 5 sets for the movies watched. So 15, 2, 17, and then 2, and then 2. So there's my 2 sets. My sample size is only 5. It's a very small sample. And the question would be, with that small of a sample, can I get reasonable results that will help me to predict for the whole entire group? Now, I'm going to go ahead and quit out of this window just so that you can see what I can do now with those lists is I can do some calculations on them. So I'm going to use this second stat button, and I'm going to go over to math and then down to these two, mean and median. So I want the mean and median now for lists 3 and 4, because those were the two that I just did the sample sizes for. So the mean for list 3 is 7.32. So that's the hours of sleep, the average hours of sleep, or mean hours of sleep. And the same thing, second list. And this time I want to find the median for the same list. So second list, list 4. So there's my, so that one came out at 2. The median was at 2. So my median for hours of sleep at a sample size of 5 is 7.32, sorry, my mean, and my median, and I actually want mean and median for both. I'm going to go back here and get the mean for list 4. So there's the mean for list 4. So you can see there's a big variation between the median and the mean in this case. Sample size of 5 is a pretty small sample, so if we start thinking about our list and putting the numbers in order, you can see there's a bunch of 2's in that list. And so, and I need one more. I'm going to do the median for list 4 or list 3. So median for list 3. Second list, list 3. And so there's really the 4 different numbers. Median for list 3. The mean for list 3. And so actually I want to see, so median, mean, median, list 4. So the median and mean for list 4, 2 and 7.6. The median for list 3 is 7.5 and the mean is 7.32. And so I want those numbers, I want to record those numbers so that I have them for reporting to the class, because this is really a class activity, so it's really hard to do kind of the video lesson for this. But if I want to keep track, so this is my sample size of 5. And so I want the hours of sleep, and we have the mean. In this case, my mean was hours of sleep was 7.32, and the median for hours of sleep is 7.5. And for movies watched, the mean was 7.6, and the median was 2. And somebody's saying, well, why is such a big discrepancy between the mean and the median in this one? These two are pretty close. The mean and the median on this one. Remember, again, we had a sample size of 5, and median is the middle number. So if I just look at the list, list for movies watched, you can see that I had 3 2's, a 17, and a 15. And if you think about a 5-number summary, 17 would be the maximum, 2 would be the minimum, but with 5 numbers, a 2 would also be the middle number. And so the mean works out pretty evenly on this one because they even out, but the median middle number ends up being a 2. So my sample size of 5, and sort of again, one of the questions we're going to want to ask is the sample size of 5 enough to give us reasonable answer in terms of what would be correct? Now that's for sample size of 5. But what if we go back and we actually increase the sample size to 10? So if I say my sample size is 10, and I go back and I'm going to do a new sample, I'm not going to use the ones I've already chosen, or they might come up again because remember it's random, and random doesn't necessarily mean that you're excluded. It's you have another chance. So this time I'm going to use my yellow highlighter, and I'm going to go back to my calculator and clear all this out, and I'm going to now pick randomly again. So math, go to PRB, probability, down to random integer, and 1, comma, 100. So there's a comma button just above the 7. So you can do the 1, comma, and then close the parentheses just above the 9. So 1, comma, 100. I'm going to hit enter. Now I'm going to do this again. I'm going to pick 10 randomly from the list. And again, they could have already been picked before, because remember, sometimes you get picked again because it's random. And so 80 is the first one that I'm picking up, and that would be right here. So I'm going to pick 10 now this way. So 1, and then for number 43, 2, that's my second one. And then number 60 is chosen at another time. 60, and then 41. 41 got picked in my last one, so I'm going to pick it again. I can mark it there. 41, 16, 16. See, this is random, so this doesn't mean that you don't get picked again. It means you can be picked every time or never. And then 39. And see, how many numbers do I have? That's 6. So my 7th one is 29. And then the 8th one is 12. And then 9th one is 12 again. So I've already picked 12. It's in my sample. I'm going to skip it and pick another one. Number 13. And then that's 1, 2, 3, 4, 5, 6, 7, 8, 9. I need one more for this sample of 10. Number 54. And that one has not been chosen before. And so there now I have my sample size of 10. I'm going to do the same thing. I'm going to go in my graphing calculator, and I'm going to go into my lists. So stat, enter, and list 5 now is going to be my hours of sleep for my sample size of 10. So now I'm going to have 10 numbers in here. 9.2, 8.5. Make sure I get this one here. 8.3 and 8.2, 7.4, 5.5, 7, and I should have a few more over here. 9.1, 9.5, and one more, 6.5. And that's my 10th entry. That's good. So I have the right number of entries. And so now I have 10 from that sample size or sample group for hours of sleep. And now I'm going to go over to my last list, list 6, and I'm going to put in the movies watched. Let's see what we get here. So 10 and 5 and 2 and 2 and 6 and 17, 5 and 15, 1 and 0. And that's my 10th entry. So there's my sample size of 10. So now in list 5, I have a group of 10, my sample size of 10, movies watched, or hours of sleep, excuse me. I have movies watched in list 6. So now I have all that data. And now I want to find the mean and median for each. So I'm going to quit out of this, and we're going to clear this out, and we're going to go math. Sorry, we're going to go second stat, this one, because we want to do some math in this window. And then down to the mean. And then I'm going to pick list 5. That's sleep hours. That's the mean. So 7.92. Keep track here. So hours of sleep. And that mean was 7.92 hours sleep. And now I need the median for the same group. So we're going to go back here, calculator, and second, stat, math, median, second, stat, list 5. That's my hours of sleep list. And so 8.25 is the median for my sample size of 10. And then now I need for movies. So I'm just kind of keeping a chart here, keeping track. So movies watched, I'm going to do the same thing. Second, stat, math, down to mean. And then list 6 is my movies. There's the mean, 6.3. That's the mean. And then I want the median, so we do the same thing. Math, median, second list 6. And I get 5 for the median for my sample size of 10. And now what I'm going to do is, so there's a sample size of 5, there's a sample size of 10, and you can see that the means, some variation between them. And this is really one of the reasons why, as a class, what we're going to do with this is put all this data together and see if this averages out okay. But I just want to look at my own data for a minute here, because I did do a sample size of 30 already. And so I'm going to actually record the hours of sleep, the mean, and the median for that sample size of 30, and for movies, the mean and the median, because I have that data in my calculator already from the previous lesson 2.3. So I'm going to go ahead, and they're actually in my lists 1 and 2, so you can see in my list 1 and list 2. My list 1 is my sample of 30 for hours of sleep, and my sample of 30 for movies watched. So I'm going to go ahead and see what I got for means and medians for those. So second, stat, math, mean for list 1, and that's 7.75 we'll round off to. So 7.75 is my mean for hours of sleep, and then let's find the median. Math, median, middle number. If I were to put these numbers in order from least to greatest, this would be the middle number. And I want list 1, 7.8. And then for movies watched, which is in my list 2, I'm going to do the same thing. The mean for list 2 is 3.83. Round that off. And the median for list 2, which is my movies watched, is 2. So here's really the issue or the question. In your book, it actually tells you that the actual median number, it says right here, the median number of movies watched for all 100 students, if you actually did calculate all of them, is 3. So the actual median for movies, the actual median number is 3. for all 100. So all 100, the movie's median is 3. Not 30, just 3. Okay. And I got 2 in my sample size of 30, I got 5 in my sample size of 10, and I got 2 in my sample size of 5. And the actual is 3. So the question is, which of those sample sizes gave me the closest and most accurate data? Well, it looks like all 3 of them worked pretty well in terms of that data. So it's hard to say because these are just my results and they may vary from other students' results. The other thing that the book tells us is that for the entire population, the mean number of hours of sleep for sleep, the mean is 7.7 hours. Now, if you think about that, for all 100 students, the mean is 7.7. I got 7.75 in my sample size of 30. I got 7.9 in my sample size of 10, and I got 7.32 in my sample size of 5. So did I need to do a sample size of 30? Was that more than necessary to get a good indication for that? It would be interesting to go back and actually find the mean number of hours of sleep and the median number of hours of sleep and the mean number of movies watched and see how those follow. Now here's where this really plays out. So here are some results that I did with the class, and since this is on video and you may be doing this at home, this is what happens, and this is what we really want to see. So here's a line plot for movies watched, a sample size of 5. And this is a whole bunch of different people's data put together, different means that people got for sample size of 5, and then a sample size of 10. And then finally a sample size of 30. And kind of the thing to notice is what happens is as the sample size increases, if we go from 5 to 10 to 30, the variation or the distribution of the data. See, this one I have one way down here at 1 to 1.5, and we have one up here at a whole bunch up here at 7.5. Those go away as we get, at least there's fewer of them, as we get a greater sample size. So what if we look at another one? So if I have a line plot for, again, these are the medians for movies watched. And this is a whole set of class data, a whole number of students did this. And so you can see with a sample size of 5, there's a lot here in the middle, but there's also a bunch way out on the edges. Sample size of 10, okay, some of those ones further on the edge start to disappear. Sample size of 30, most of the data falls right in here where the median is right around 3. And the actual median is 3 for movies watched. So the larger the sample size, the more likely you are to get a number that is actually related to the entire group. So kind of the idea here is that the bigger the sample, the better the results. Even though mine turned out pretty good for a sample size of 5, I just kind of got lucky. My sample size of 5 actually was pretty close to the actual means and medians. Okay. And in some ways my sample size of 30 was not as accurate, but sometimes that can happen. If I look at the line plot for hours of sleep for the means, so here's a sample size of 5. Notice how it's kind of spread out. The distribution is spread amongst all the way from 6 to 9, and sample size of 10, still 7 to 9, but bars in the middle begin to get taller and the bars on the end begin to diminish, and you're more likely with a larger sample size of 30 in this case, or if we look at the median, same idea, we have some way out here in the edges Okay, a bunch here. Sample size of 10 starts to move to the middle, and then you look at your sample size of 30, and we're actually right in the median, where the median should fall around 7.5 hours of sleep. And we knew that from our previous experiment that that's where they were. But the sample size, again, as you increase your sample size, you increase your accuracy, which makes sense. Obviously, the most accurate way to do this would be to take all 100 and find the mean, all 100 and find the mean and median, and you would have the exact accurate. But now what we're talking about is that when you're talking about a sample size, if you had 1,000 people, how many of those 1,000 people would you actually have to survey in order to be able to predict for the entire population? If you had 10,000 people, how many would you need to survey? If you think about our survey, if you took 5 out of 100, that's only 5%. If you took 10 out of 100, that's only 10%. If you take 30 out of 100, that's 30%. Well, you have to kind of sort of imagine if you're trying to do a survey of everyone in the United States and you're talking about 300 million people, how many people would you actually have to talk to in order to be able to predict for the entire population? And so you can see how difficult this becomes, because 5% of 300 million people in the United States is a big number of people. And so we were able to predict, but there's some error. And so when you have a smaller sample size, you have a greater opportunity for error than you do with a large sample size. But we generally take small sample sizes because the larger the sample size, the greater the amount of work there is to do. Imagine doing a sample of 10,000 people and trying to do all the work with that data, as opposed to a sample size of a couple thousand. Now, if you are paying attention to polls that they do on TV or for newspapers and those kinds of things, magazines, most often those polls are only polls of a couple thousand people, sometimes even down into the 100s. And they will use those polls, just like we have used these samples, to predict for much, much larger groups. And so understand that sampling is not an easy process. It often, especially with a small sample size, leads to errors. And so it's hard to predict for an entire population with a small sample size. But we do it because sometimes we want to be able to try to make predictions. That's what the mathematics of statistics is most often about, is either charting what's happened so that we can predict the future of what will happen, or sometimes just trying to understand and know a certain situation. And so this lesson really is kind of impossible to do just on your own. This really is a class activity, and so the data I'm showing you here is from an actual class that did this activity. And so if you're doing this again at home, you're going to probably need to come into a class or be in a class where you can share data with other students in order to see how this actually works. But the basic process that I went through is one that you can use at least to get started on this activity and see how it works for you. So that's lesson 2.4.